So today we're going to talk about a specific type of discrete random variable called the binomial distribution. And as you take your notes today, if there's anything that you have questions about or are uncertain about, maybe star them or flag them in your notes, and then we can discuss them in class next time we meet. So the first thing that we need to do is discuss what makes something a binomial random variable or a binomial experiment. So there are certain criteria that have to be met. And one of them is that you repeat this chance process for a fixed number of trials, and each trial is independent of the next. So it could be something like shooting baskets or flipping a coin, as long as we know upfront how many trials we're going to complete. The other criteria that need to be met is that we have just two possible outcomes for each trial, a success and a failure. And this doesn't necessarily mean that there's only two outcomes. If you were doing something like rolling a die, this could be considered binomial if you considered either maybe the evens versus the odds, or if you labeled a success as, we'll say, rolling a one, and a failure is everything besides rolling a one. So even though there are six outcomes on the die, if we can just put them into two separate categories, we can categorize those into successes and failures. The third criteria is that the probability of success, so this notation here, probability of S, is the same for each trial, which really is kind of tied to the independence piece. And then what we're interested in is calculating the number of successful trials in a certain set of chance processes. So, really, what we look at, or when we're trying to see if something fits this binomial experiment, is we have some conditions that we can check. And so, an acronym that you can use is BINS. And so, B means that it's binary, so that you have success and failure. I is for independence. And then N is for a fixed number of trials. And then S is for that fixed probability of success. So if you can kind of check off those four criteria, then you're going to be able to use the rules that we're going to learn today for calculating probabilities of binomial experiments. We have a formula for the mean and standard deviation of the distribution. So we're going to see all of those in class today. We have to make sure that these four criteria are met before we can use these rules. So here's just some notation that you'll see in your textbook. N is going to be the number of trials. And then in your textbook, you use P and Q. P is just the probability of success, and Q is the probability of failure. And then X is the number of successes in that fixed number of trials. And so it's important that we recognize what these variables represent because they're going to show up in our formula here in just a minute. So here's an example. We're going to identify the N, the P, and the Q here. So N is the number of trials. So it tells me that the doctor performs the procedure on 8 patients. So my N is going to be 8. P is the probability of success. So there's an 85% chance of success. And when we plug our formula or plug our numbers into our formula, it's going to be that percentage as a decimal. So it's going to be 0.85. And then Q is the probability of failure. So if there's an 85% chance of success, there's a 15% chance of failure, so 0.15. I can use the complement rule to find this number. I can just take 1 minus the probability that it's not successful to find that failure. And this would meet the binary conditions or the binomial conditions that I talked about on that first slide. So B is that it's binary, so either the surgery is successful or not. And then here, it doesn't come out and tell me that the trials are independent, but we can assume independence here. The surgery being successful on one patient is not going to influence any future success or failure. We have N, we found that here to be that 8 patients. And then we have that fixed probability of success. That was that P equals 0.85. So it satisfies those bins. We can identify these variables, and then we'll see how we can calculate probabilities here in just a minute. So here is our binomial probability formula. So if we want to calculate the probability that we have X successes in N trials, we're going to use this formula over here. And so it does look pretty complicated, especially with this N over X here in parentheses. But this is really the same as saying N choose X or NCR, which we just looked at recently. So you'll find that value by using the NCR function on your calculator. That replaces this piece here in parentheses. And then it's the probability of success to the number of successes, probability of failure to the number of failures. So we'll see how we can use this formula with an example in just a moment. You can also calculate probabilities using Staplet, and I'll show you that once we're finished with the notes today. It's located under the normal distributions and probability heading. So you'll see that title, and then right underneath it, it says binomial distributions. So clicking on that will open up the screen you need. If anybody has a graphing calculator, you can find the probabilities there as well. There's a binomial PDF and binomial CDF option under the distribution menu. So you would have to hit the second button, followed by the variables button. That's going to open up that distribution menu. And if you scroll down, you'll see that PDF and CDF option here. And the way that these work is it would be the binomial PDF for exactly X successes in N trials. And this is your input, number of trials, probability of success, and then how many successes. Or sometimes you're interested in the probability of X or fewer successes. So that would be the CDF option, number of trials, probability of success, and the number of successes. So if you have the graphing calculator, you can try that out. If you don't need to worry about it. You can always use the formula or Staplet. So we are going to look at this knee surgery example, and we will calculate a probability using both the formula, and then I'll go into Staplet and show you how that works as well. So again, before we use the formula that you just saw on the previous slide, we have to make sure that it's appropriate to do so. So we have to make sure that those bins are satisfied. So this is very similar to what we just saw. It's a surgery example, so either it's successful or not. We can assume that the success is independent. We have a fixed number of patients here. It says in this case that the surgery is performed on 3 patients, so N is equal to 3. And then our probability of success is 75% here, so 0.75. So now we can find the probability that the surgery is successful on exactly 2 patients. So this is going to be our X. So we want to know successful on 2 out of those 3 patients. So in order to do that, we can use the probability formula for binomial distributions that was on the previous slide. We're going to find the probability that X is equal to 2. That's going to be equal to that binomial coefficient where it would have been 3 over 2 in that big set of parentheses. But instead, we're just going to use that NCR notation because you guys are familiar with that. So NC and then whatever your X is. So here 3C2. And then it's the probability of success. So 75% chance of success to the number of successes. So that's to the second power. And then the probability of failure. So 1 minus 0.75, or we can just put in a 0.25 there, to the number of failures. So if there were 2 successes out of the 3 trials, there's 3 minus 2, or just 1 failure. So I can simplify this a little bit before I start plugging things into my calculator. I've got 3C2, 0.75 to the second, 0.25 to the first. So then I'm going to go to the probability menu on my calculator to get the value for 3C2. And that value is 3. So I take 3 times 0.75 to the second power times 0.25 to the first power. And that gives me about 42%. So the probability that I have exactly 2 out of 3 of the surgeries being successful is 0.4219. Again, I'll show you how to find this in Staplet momentarily. If you had the graphing calculator, you would go into that second variables menu, and it would be the binomial PDF. Since it's exactly 2 out of 3 successes, I would say 3, P is 0.75, and then 2. And that would also give me 0.4219. So just another way to get the same solution. So we can also look at what the binomial distribution looks like as a graph in a histogram form. So just like we did with discrete random variables. Your table will have the X values and their corresponding probabilities, and then you can use that chart to make a relative frequency histogram. So we're going to do that here in a minute using the knee surgery example, and we'll pull our probabilities from Staplet so that you guys can see how that works as well. So no changes here. In terms of the knee surgery, this is the same example that we just looked at. So if I want to look at what my distribution looks like, I can make a T-chart with my X values and then the corresponding probabilities. And so I have to think about what's happening here. I'm performing the surgery on 3 patients. So I could potentially see no successes. All 3 of those patients had an unsuccessful surgery. I could see 1 success, 2 successes, or 3 successes. I can't see any more than 3 successes because it's only performed on 3 patients. So essentially your T-chart will always have X values that range from 0 up to N. To fill in the probabilities here, this is just going to be the probability of that number of successes. So using that NCR formula, so NCX, probability of success to the number of successes, probability of failure to the number of failures. And we can get that either by using this formula here or by pulling those values from Staplet. I can go ahead and fill in the value for 2 successes because we just found that. But then to find the rest of these, I can go into the formula or I can go into Staplet. So I'm going to go ahead and switch my screen here to Staplet for you. So when I go to Staplet.com, like I said, it's under the normal distributions and probability menu. And then I click on binomial distributions. When I do that, I have a spot here for me to type in N. So N in this case was my 3 patients. P, which in this case was the 75% chance of success. And then so from there, I can go ahead and I can say plot distribution. And this is going to go ahead and give me my histogram, which we're going to create in just a minute. But if I hover over each of these bars, it shows me that probability of getting 0 successful surgeries is 1.56%. 1 successful surgery is 14.06%. 2 we already had, and then 3 is the 42.19. So I'm just going to record those numbers real quick here so that I can throw them back into the PowerPoint. And then I'm going to show you a couple more things on Statlet. So in addition to getting those values from the histogram, you can also calculate some probabilities down here. You see that I have the option to calculate the probability of exactly, and then here I could say exactly 2 successes like I did on that previous example. And then I just click go, and it will show me that probability on the histogram, and then it gives me the probability here. The other thing that I could do is maybe I was interested in finding the probability that there were 2 or fewer successful surgeries out of 3 patients. I can change my drop-down menu here to at least, which would mean, well, I should say at most, so 2 or fewer would be 2 or less, at most 2 successes, and that's going to give me all of this region here. And essentially what it's doing when it calculates this 57.81% is that it's summing the probabilities from these 3 bars here. So it's taking that roughly 42% that we calculated, the roughly 14% here, and the roughly 1.5% here, and adding those 3 together. So you can manipulate this to find more cumulative probabilities as well. Statlet also finds your mean and standard deviation here for the distribution, and we'll see those formulas in the notes in just a minute, but I'll point that out for you at this point. You can always manipulate your values. So say you had, instead of 3 patients, say we had 10 patients, still a 75% success rate. If I click plot distribution, you can see that that changes things here quite a bit. So I would basically have almost no chance out of 10 patients of seeing 2 or fewer successful surgeries. Then up here at 3, I still have a very small chance, but it looks like typically I'm going to have about 7 or 8 successful surgeries if I have 10 patients. And I can see that with my mean here of 7.5 as well. So let me go ahead back into PowerPoint. So if I fill in these probabilities that came from Statlet here, this first one was the 1.5%, so 0.0156. This was the roughly 14%. And then this one here was, hang on, I recorded the wrong one. I'll just plug it into my calculator's formula here real quick. Okay, this is 0.42. I guess with the rounding, it does round to be the same. So then if I wanted to make the histogram, I would go ahead and put my number of successes on my x-axis. And I would put my relative frequency, or I could say probability, on my y-axis. And when I go to scale here, I just want to look to see what my largest value is, so roughly 42%. So maybe I count by 5% increments. I'm out of space here. And then I put those bars in. So I would have my 0, 1, up to 3 successes. So for 0, I've got a very short bar here, and you can kind of estimate if needed. And then I'm up to about 15%, and then up to that roughly 42% here for those last couple. So I can always find the mean, which is really the number of expected successes. Just by taking n times p. So number of trials times probability of success. Standard deviation, I'm going to take n times p times 1 minus p, or I can say n times p times q, and then I take the square root of that value. So this tells me typically how much I expect to vary from the mean. And again, Staplet will get these for you if you choose to use that, but the formulas aren't all that complicated, so you can also just plug in as well. So for your assignment, you guys are going to just complete the application problem about the number of late trains on the activity worksheet. Again, as you go through, if you have questions, if you're not sure you're doing something right on the worksheet, just make note of it. We can discuss that in class next time we meet. Or if there was anything from the notes that was unclear, make a note of that, and then we'll start with that during our next live session.